Welcome to 58th lecture in the course of Industrial Engineering and Operations Research. We are discussing inventory models, and in the last class I told some models mostly based on the book of Taha about the probabilistic inventory models. Now today we will continue with one example which is also based on the book of Taha, but naturally these values etc. are different. So suppose the problem is that an industry uses adhesive fluid in its manufacturing process at the rate of 1000 gallons per month. It costs rupees 5000 to place an order. The holding cost per gallon per month is rupees 20 and the shortage cost per gallon is rupees 100. Okay, that is the shortage cost. Historical data shows that the demand during lead time is uniformly distributed in the range 0 to 100 gallons. So here we are not assuming normal distribution, we are assuming that during the lead time demand can be from 0 to 100 gallons. Okay. Anything between that, and it is uniform, equal chances are there that it can be between 10 to 20, it can be between 20 to 30, it can be between 30 to 40, like that it is equal chance. So determine the optimal ordering policy means how much we should order and how much buffer stock should be kept. So given data is that D means demand in a period, a specified period, let us say take the origin of 1 month, in that 1000 gallons, and K is equal to, that is you can say the setup cost or ordering cost, that is rupees 5000 per month. So if you want to place one order, you have to pay 5000 rupees. H is equal to holding cost is rupees 20 per gallon per month. For 1 gallon 20 rupees in 1 month. Now shortage cost is rupees 100 per gallon. So per gallon shortage cost, that means if you are not able to supply 1 gallon, you in a way you are losing 100 rupee due to loss or whatever that thing. Now demand is in during the lead time is uniformly distributed. So it is in the range of 0 to 100. So therefore probability density function is what? It is 1 by 100. Okay. So probability density function, as you know, that we plot here, that suppose we say PDF and here may be quantity x on x axis. So it is uniform, that is 1 by 100, like that. Probability density function is not the probability, that is for finding out the probability you have to find out the area. Okay. PDF is Fx is equal to 1 by 100. In fact demand is 0 to 100 gallon. So it is basically you can say per gallon. Okay. So you have to say if quantity, this is quantity in gallon, so gallon has to be multiplied. So therefore what happens that here, if you want to find out the probability that demand will be exactly 50, that will come out to be 0, because you know, see, there is no area. But if you say yes, what is the probability that demand will be between 40 and 50, then you can take this area 40, 50, okay, between 40 to 50. Okay. So this you have to understand very correctly. Now what is the question is that what is the expected demand? Expected demand, or we can also say the mean. It is in uniform distribution case, it will come 50 gallon. How you will find out that area? That means this value. So Ex can be found out as integration between 0 to 100, because demand is, and Fx and into x dx. So Fx dx is a small probability plus the quantity at x. If you multiply that, so it will come out to be 50. So what happens that here, suppose you say 0 to 100 and x 50. So x into 50 into dx, not 50. This is Fx is basically 1 by 100. So, x by 1 by 100, right, because probability density function into x into dx. So, if you do this, then what will happen? This becomes x square by 2 integration. So, it becomes x square by 2, x square by 200 rather, and limits are 0 to 100. So, it becomes what? 100 into 100 divided by 200, other thing will be 0. So, it comes out to be 50. Okay. So, 50 gallon is the expected demand. Now, first step was that I told in that algorithm that we have to see that whether the problem has a unique solution or not, that we have to find out. I am just putting the slides of the previous one, that we had made one model, and in that model we had made many assumptions. That was unfilled demand during lead time is backlogged, no more than one outstanding order is allowed. The distribution of demand during lead time remains stationary with time. So, that we are considering it is uniform distribution. To develop the total cost function per unit time, let fx will be PDF of demand during lead time. Note x is unit of item. So, in our case it is per gallon, and this is fx is equal to basically 1 by 100 here, and expected demand per unit time is we have already calculated, that is it is coming 50 because it is uniform. Holding cost per unit time is given, sorted cost is given, it was I think rupees 100 per gallon, right, and setup cost per order was given, I think it was rupees 5,000, and holding cost was also given. Holding cost was per gallon per month rupees 20, rupees 20 per gallon and per month, right. So, this data is given here. Now, we had equations y hat is equal to something 2d k plus p ex h. Just we substitute the value, we get something like 1000, and here it was y tilde. Due to some distortion, it is percentage type of sign. Here it comes, it is due to compatibility of the computer. So, don't worry about that. You consider that this is y tilde is equal to PD by h, and that comes out to be 5000. So, y tilde 5000 is greater than y, therefore, a unique solution exists for y star and r star, and S is computed as R 100 to, this was the formula for total shortage, that this was R to infinity x minus R fx dx. So, we are putting x minus R 1 by 100 dx, and this becomes R square by 200 minus R plus 50. That means we have calculated, and we had said the optimal value of y and r can be determined in closed form, cannot be determined in closed form. Algorithm converges in a finite number of iterations. So, we have to do that. Suppose we take r is equal to 0 to begin with, then y comes like this and this y tilde comes like this. Unique optimal value comes when this is equal to this. This was already I told. Smallest value of y star is under root 2 kd by h. That is simple normal EOQ type of formula. It occurs when s is equal to 0. So, if you calculate using s in the following equation, if shortage is also you include, then it becomes y star becomes this, and if you want to do iteratively, then yi any iteration under root 2d k plus ps by h. If you put the value, then at any iteration you get yi is equal to this 500,000 and this is 10,000 s, like that you get. And using the relation, now we had a relation r star infinity fx dx is equal to hy by pd, and if we put that this one, so this becomes like this, and if you solve it, then it becomes basically, if you simplify at any iteration, ri is equal to 100 minus yi by 50. So, we have written two equations in proper form. One equation is this, other equation is this, and now we have to keep doing that things. So let us start with iterations. Suppose first we calculate without any shortage and we got something this one. This value of y1 is substituted in this one and we get r1. Once we get new some value of r1, then that can be put in the equation and you can so this we got r1. Okay, I think r2 we wrote, maybe that here r2. Basically we can say at iteration 2 we can say this is r2 and we can put it here r2 square by 200. Shortage cost is this. So in this shortage expression we put the value and we obtain shortage, and then we find out y2 is equal to this much, 500,000 plus 10,000 is, and we get new value of y2 which is different from y1. But again we find out that basically that this value, based on that we calculate, suppose y2 we found, r2 basically it is r3 we can say, and we get r300 minus this one, and this value is again iteration, some cut paste problem is there, this is r3, it is r3. We put that value and we get some this value, s is equal to this, and then we put y3 is equal to this much, and then we put something like that, and then we keep doing these type of things. Okay, we go to iteration 4, we do the same thing. You can do these type of things, okay, this iteratively, okay, and you put here, you keep getting y4 and r4. In iteration 4, suppose latest value of r4 from previous iteration, this is taken and this is put it there, you get like that, and then you get y5, you take the latest value of this and then you get this, and therefore r5 is equal to this much. Now you stop that when there is no much change in the consecutive values of y4 and y5, and no, similarly there is no change in the value between r4 and i5. So the optimum value has been given, that is 85.71 gallons. So that means this is the buffer stock. Okay, that means you have to keep this one buffer stock like this. That means as soon as you maybe get 85.7 gallon quantities left, you should place an order, and y star is equal to 714.29. That means you order 714.29 gallons. So we did this problem in iterative way. Of course, it will take more time to do. So how do we proceeded? That we started with that, suppose we assumed or by economic order quantity method, suppose we got yi is equal to 707.16, and then corresponding ri came out to be 85.86, then it came 774 then 84, then 715, like that finally we converge to this value. So this type of procedure can be adopted in probabilistic one. Now I am going to discuss say somewhat different topic, okay, and this is about single period models. Okay, this is very interesting topic, little bit different. Till now we were discussing about those type of situation when you know continuous production is going on and you keep ordering the quantities for each period, and then after that you order for next period, like that it goes, and this process goes you know always. Okay, this is something it will continue. But in the single period model we are concerned with such type of situation that I have to order once. There is no question of holding etc. Say suppose a fruit seller is there, he will go in the market and maybe he will purchase some banana, and these bananas he has to decide that you know how much time he has to take. Maybe suppose you say that banana can be stored only for 3 days. After 3 days those bananas will get waste. Similarly, a newspaper man goes in the market and he purchases the newspapers in bulk, but in the after that day is over, then those newspapers have to be thrown away. Maybe he may get some money because of the paper cost, means that something like we can say salvage value, but otherwise it is just wastage. So, if he has some idea about demand and demand is variable also, so based on that he has to take a decision that how much we should order. So, it is somewhat a different way, but there is a much similarity with the our inventory management system, that same thing. When we talk about rather than the holding cost, we are concerned with a similar thing which is like a holding cost, but it is something that if you order extra and if something is then how much loss you got. There is no question of holding that because I am holding that thing, that because it is straightway some loss. Okay. So, there is a similarity, but we will just discuss that point in detail. So, single period models in inventory management are used for decision making when an item is ordered only once for a specific period. Say for example, I am going to purchase the newspaper, this is for today only, it is for today only, and after that there is no question that it can be this one. Of course, it can repeat, next day I will go and purchase another type of newspaper, but decision has to be made about today itself. Similarly, you can say if I purchase a banana and one banana can be stored for 3 days, then it is something like one type of situation. There is no question of that, okay, I can decide and I let the holding cost increase, I can hold it for 10 days or something like that. This is not the question here. Okay. Because unsold items cannot be carried over for the next period. Okay. So, period may be there, that may be continuous process. Daily the person is purchasing. At the end of the period, leftover quantities are disposed of. So, we say that at the end of that, if you purchase, they have to be disposed of. So, here the objective is to we will not say precisely that it is balancing between the holding cost and ordering cost, rather we say the objective is to balance the cost of ordering too much. Suppose we ordered too much, so there we used to say that holding cost will increase because at one go you have taken so many items, but here you are ordering too much, so you will be doing overstocking. Overstock is there, that means you have got and of course and if you order very less, then you say ordering too little, means you say stock out situation, stock is out, people are demanding but stock is out, and loss, it is also called lost sales, that means you could have got that sale but you lost it. These models are typically applied in industries like newspapers or seasonal goods like vegetables, etc. Newspaper, in fact, this problem itself is called newspaper model. Okay. Newsboy model, such type of names are there, but that does not mean it is for only that situation, it is useful for similar type of situation. But to make it interesting, many researchers have taken this problem mathematically, that how a newsboy will decide, newspaper boy will decide that how much to order. So, in these problems demand is uncertain and leftover inventory has little, it has some value maybe or no value, or it may be 0. So, a single period inventory model describes a situation in which one order is placed for a product. At the end of the sales period, any remaining product has little or no value. Examples are seasonal goods, bakery goods like bread, people purchase, eat in the morning bread butter. Okay. So, bread comes in from the market, maybe curd also, curd will go bad, milk also, newspapers and magazines. In other words, even though items are ordered weekly or daily, like you purchase milk daily and daily it comes, some Amul wine comes and it gives you milk. So, the shopkeeper has to decide that how much it should keep, so that the customers should not go without this one milk, and they should get, so that they should get confidence in that shop. But at the same time there should not be excess purchase, because so many packets of the milk which comes in the polythene packet, those may get waste. So they cannot be held over and used as inventory in the next sales period. Therefore, the decision is to be made on how much to order at the beginning of the period. So here we can have symbols used in the development of model. Setup cost per order, holding cost per order. We used to make this type of model. Penalty cost per shortage unit during the period. FD was probability distribution function of demand. D during the period. Y is the order quantity and X was inventory on hand before an order is placed. Model determines the optimal value of Y that minimizes the sum of the expected holding and shortage cost. We say given optimal Y is equal to Y star, the inventory policy calls for ordering Y star minus X if X is smaller than Y, otherwise no order is placed. This we did that. Okay. But here same type of things, but slightly different notations. So here no setup model, we are discussing no setup model, means setup cost is not there, and this is some books it is called also news vendor model. This model is known as the news vendor model. The original classical name is the newsboy model, that also by that name also you will get in the Google. It deals with stocking and selling newspapers and periodicals, means magazines. Assumptions of the model are demand occurs instantaneously at the start of the period, immediately after the order is received. No need to hold etc., because he will go at the morning 6 o'clock and by 7 o'clock in each house he want to give the newspaper, means as early as morning. After that whole day is free, only morning newspaper is sold. No setup cost is incurred. That means he for ordering that thing there is no question of setup cost. That so there are setup with setup cost models also. That is one topic ahead. That means we can add that also, but right now we are making things simple. There is no setup cost, just he goes and purchases that. Characteristic of this model are as follows: single period, decisions are made for a single selling season or period. That means you make the decision for this one day, no need to make strategy for whole year. Uncertain demand, demand is not known with certainty in advance. That's why you are doing, if demand is known then nothing is left. If he knows that there will be demand of say 300 newspapers, so he will purchase 300 newspapers. Limited shelf life, inventory cannot be held over the next period, meaning excess inventory has little or no value if the paper of 5th July is useless on the 6th July. Okay. So this is we can say graphically that situation. Figure demonstrates the inventory position after the demand D is satisfied. If D is smaller than Y, suppose we ordered Y quantity and my demand is D, then naturally Y minus D is held during that period. That means this is something excess amount got over stocking. And else a shortage amount, suppose sometimes situation is this, that you took Y but the demand was D, so D minus Y is the shortage amount. So D minus Y will result if D is greater than Y. So this is the shortage cost. And expected cost for the period, we can say in the simple way of the expected cost, because we don't know that demand can be anything, demand is variable. So expected cost will be H0 to Hy minus D into Fd, D. So suppose distribution of demand is given by Fd, that means PDF of the demand is given by Fd, so Fd D and Y minus D. So Y it is excess, so this is because of the overstocking or overaging, Y minus D Fd, and here it is plus P Y to infinity D minus Y Fd into Dd. That type of simple thing is there. In the book of Taha, if you see the maybe 6th edition and if you see 10th edition, then there is some type of that difference, okay, in the way of writing the expression. Deep down they are similar, but this may create lot of confusion. Therefore, I will give the derivation part of this from based on a different book, but I am just explaining the basic concepts. There should not be any this one. In the previous version, Taha also includes in the cost that basically the cost of purchase. Okay. So, those type of things can be, but these can be taken. Okay. So, now we already discussed in some early module about the single period model. Little bit I am revisiting that type of thing again, and then I will come back to the more mathematical expression. That time I only told some problem, and we did not go in too much depth about the probability distribution, etc. So, let us revise that. The exact demand for such seasonal product is never known, hence a probability distribution related to demand is considered. And I told that time, if normal distribution is assumed and the management is stocked and sold an average of, I give the example of Christmas tree each season, so it is something like 100 Christmas trees, then there is a 50% chance that would stock out and 50% chance that would have trees left over. That means, if the mean demand, suppose I assume it is normal and I purchased 100 Christmas trees, then 50% chance is that you will get a stock out situation, 50% that it will be overaging. To determine the optimal stocking policy for trees before the season begins, management needs to know the standard deviation and consider two marginal costs, that cost of shortage and cost of overage. We are just telling them marginal cost because they indicate some type of difference between two quantities. That cost of shortage, that means due to shortage how much you are losing, and cost of overage means what will be the loss. Something like if you purchase something in 50 rupee, but you know that next day it become almost useless, but it could be sold in 10 rupee, then your cost of overage will be 50 minus 10 means 40. So, CS is equal to cost of shortage. Shortage will occur if you underestimated the thing, and it will be sales price per unit minus cost per unit. So, that means sales price whatever you are selling, but you purchase, and what the cost. So, it is not that you are getting something loss, but in a way something which you could have got, you could have got it, but you are missing that. So, that is called shortage. Okay. This is the cost of shortage. That suppose I purchased 2 items only, but and each one is costing say something like 50 rupee, and I was selling it at 75 rupees, but there was in fact a demand of 3 items, but I had purchased only 2. So, I would say that, oh, I incurred a loss of 25 rupees. Okay. Because what happens that if I would have purchased, then today 25 rupees would have been in my pocket, because I would have paid for that item only 50 rupee, but by selling I would have earned 75 rupees. So, that is why they say it cost of shortage. Cost of overage, that means you are overestimated something, you thought that there will be demand of say 5 items, but actually only 3 were sold. So, 2 you got a loss of 2. So, per unit it is something like cost per unit minus salvage value per unit. As I told that if you purchase something in 50 rupee, next day it could be sold only in 10 rupee, then cost of overage is 40. Sometimes salvage value can be 0 also. Then we define that there is a called service level. The probability of not stocking out should be equal to or more than the ratio CS by CS plus C0. This formula has come, and this is what little bit will derive, that CS by CS plus 0. But let us do that one problem before that we go in mathematical. You can take it on face value that this is basically CS by CS plus C0, that is called this one, that ratio, and based on that you decide. So, suppose a newspaper seller sells 125 copies of a newspaper each day. He believes the sale of the newspaper is normally distributed with a standard deviation of 15 papers. He pays rupees 3 for each paper and sells for rupees 5. He is given a rupees 1.5 credit for each unsold paper. That means he gets back rupees 1.5 if paper is not sold. That means he can return. He wants to determine how many papers he should order each day and the stock out risk for that quantity. So, what we have to do, that CS means cost of shortage, sales per unit minus cost per unit, that means rupees 5 minus 3 to rupees 2 per unit is the shortage cost, and cost of overage is cost per unit minus salvage value per unit, this is rupees 3 minus 1.5, that means rupees 1.5. So, CS divided by CS plus C0 will be 2 divided by 2 plus 1.5, that value comes out to be 0.571. So, now the Z value has to be determined, evaluated, that yields a probability of 0.571, that means we have to get a probability of at least 0.571. So, Z value is what? When we plot a normal distribution in normalized form, when the mean is 0 and standard deviation is 1, then this quantity on the x axis is basically Z. Okay. This is the Z and this may be the probability. So, here Fz. So, therefore, Z value has to be this one. So, I told that you can have tables of Gaussian distribution, from that you find, otherwise MS Excel command normSynV will give that Z value of 0.1789 will give a probability of 0.571. That means, if you take Z is equal to 0.17189, okay, then this area will be 0.571 fraction of the total area. So, that means automatically came. The command normSynV P in MS Excel returns the value Z such that the with probability P a standard normal random value variable takes on a value that is less than or equal to Z. Okay. So, that means these two commands you can use. That means, we can find out the, if we have probability, then we can find out Z, or if you have Z you can find out the probability. Both the commands are in Excel, you can change. So, normSynV we used and I got Z is equal to this much. So, that means mean value is already 125, because it is seller sells 125 copies, that is average. He sells 125 copies each day. So, 125, but standard deviation is 15. So, 125 plus normalized value of standard deviation 0.1789, but now you have to denormalize it and you say into standard deviation, that becomes 125 plus 0.1789 into 5 and this becomes 128 newspapers. Okay. So, this much we will do, that got the answer, but now I will be teaching that thing mostly in the next class, a derivation of single period model based on the book Design and Analysis of Lean Production System, authored by Ronald G. Askin and Jeffrey B. Goldberg. It was published by John Wiley and Sons. So, notations I will be more or less will be following that. C is equal to purchase production cost of each item, P is equal to price per item sold, it gives you revenue, S is equal to salvage value, that means something like once it has become waste, then what is its value, that is salvage value of each unsold item. D is equal to demand, which is a random variable with probability density function Fx, and L is equal to shortage cost for each unmet item demand. In that book they have used pi symbol, but I do not want to confuse with the symbol pi, so I have used the L, and Q is equal to number of units ordered, that means decision variable. So, we find out that expected profit is equal to P minus C into Q minus L D minus Q. You will be getting for Q is smaller than D if your order quantity is less than the demand, and if your Q is more than D, because Q is the number of units order, Q is more than D, then expected profit will be P D minus C Q, plus there will be S into Q minus T, that means you will get salvage also. So, in one case you are only paying for lost value, L means lost value or something missed value. So, and then we can write that profit, they write in terms of profit, not the inventory cost, rather profit. So profit is equal to P into P means the price per unit item sold. So P 0 to infinity xf dx plus S 0 to Q Qs and Q minus x fx dx plus pq qf dx minus L qx minus q fx dx minus cq. So here first term tells revenue when demand is less than supply, second term comes salvage value, third term tells revenue when demand exceeds supply, fourth term tells shortage cost, fifth term comes cost of goods. Anyway, I will tell again in more detail in the next class. And then what has to be done? Basically, it has to be minimized with respect to q. For finding q, we have to say dE by dq is equal to 0. So this much has to be done. Okay. So I just, in order to increase your interest, I just have told, but more detail from the beginning I will be telling from in the next class. Thank you very much for the attention.